Okay, so here's a continuation of 3.4 radicals, specifically square roots are what we're focusing on here. So we're trying to simplify these, but as you can see right here, I've got the square root of 2x times the square root of 6x, and neither one of those can really be simplified. I mean, I could break the 6 up into a 2 times 3, but neither one of those are a perfect square. So when you end up in this situation, what you want to do is go ahead and just multiply them together. So what I'm doing is I'm using this property up here that we had been using to break them apart. What I'm going to do is I'm actually going to go ahead and put them back together for a second, and then I'm going to re-break it. So let's go look down here. Oops. Okay, so when I multiply this back together, that will be square root of 12x squared. And then this problem should look pretty familiar. It's like the ones we just got done completing in the previous video. So I'm going to break up this to square root of 12 times the square root of x squared. The square root of x squared, that's going to be pretty simple. Then on the 12, let's see, I can break that up into the square root of 4 times the square root of 3. And then the square root of x squared, that's just going to simplify to an x right there. And then let's see, the square root of 4 is 2. And then I'm going to put the x with it. And then the square root of 3 will go on the back end right there. So pretty much just like the problems we got done doing, except I have to multiply it together first and then re-break it apart. So we'll do the same thing on 22. This is going to be the square root of 18x to the power of 3. And so we'll go ahead and break that into square root of 18 times the square root of x cubed. Okay, so what I'm going to do here on the 18 is we can break that up into square root of 9 times the square root of 2. And the square root of x to the power of 3, I'm going to break that up into the square root of x squared times the square root of x. Now my perfect squares are going to be square root of 9 and square root of x squared. So that would give me, let's see, a 3 and an x. And then what I'll do is I'll put the other parts back together, the other parts that are stuck under the radical sign. So that will be square root of 2x right there. And there we go. Okay, I got one more slide of these. It's going to kind of be more of the same, except we'll look at it from different perspectives. So here we have quotients, and so quotients work the same way as multiplying. You can break them up to where they can have their own radical signs. So over here, see how we were square rooting a product? You could break it up. Well, if you're square rooting a quotient, you can do the same thing, or else you can also go backwards, which we'll do on problems 27 and 29. Okay, so pretty similar to what we were doing on the previous problem, except now we're looking at division instead. So what I can do here is I can break this up into the square root of 49 over the square root of 16. So that will simplify into 7 over 4. Okay. And then on 27, you could, if you really wanted to, you could try to simplify the top and then see what happens there. But the easiest thing to do in this particular example is to go ahead and put it all together as 48x cubed over 3x. And then since now that they're both inside the radical, they're both inside the same radical sign, now what we can do is we can simplify this. So 48 divided by 3, that would be, let's see, 16. And then x to the power of 3 over x would reduce down to an x squared. And now this problem is pretty simple. You need to square root 16 and square root x squared. Square root of 16 is 4. Square root of x squared is just an x. So this whole thing just simplified down to a 4x. And so that worked out pretty nice. I think this next problem should be pretty similar. We'll get something similar to this. So we'll go ahead and put this under the same radical sign. So 150x to the power of 4 divided by 3x, and then we'll simplify that, and then we'll see what we can do from there. So let's see, 150 divided by 3 is 50. And then x to the power of 4 over x would become x cubed. So it's a little bit, we got a little bit more work to do than we did on the previous one, but we've done problems like this before. So let's look at 50 first. 50 can get broken up into the square root of 25 times the square root of 2. And 25 will be our perfect square, and we'll deal with that in just a second. And then let's see, x cubed, we'll break that up into x squared square root of x. Ooh, having a hard time fitting it there. There we go. All right, so now let's see, my perfect squares are 25, which would be a 5, and x squared, which would be x. And then the radicals will create, I'll go ahead and put those together. I'll team them up, the 2 and the x. So 2x. So I get 5x square root of 2x. Okay. All right. Now the last part we'll look at here is when it comes to adding and subtracting. So I've got some notes here for us to kind of look at, to kind of get an idea of how this works. Whenever you add and subtract them, it's not really much different than adding and subtracting like terms. So like 4a plus 2a, you could factor out the a, and 4 plus 2 is 6a, right? Or if you subtract, same idea, 9b, take away 2b. You could factor out the b if you'd like. And so 9 take away 2 is 7 b's are left. So it works the same way with radicals. So I've got 4 square roots of 5. If I add 2 more square roots of 5, I have a total of 6 square roots of 5. Same idea with the subtraction. So the way you want to treat your radicals is that if you have identical ones, you either add or subtract the coefficients, okay? And so that's, I said coefficients because I almost look at the square root of 5 almost like a variable. It's not, but as far as how the math works, it's identical, as you can see from the example over here, okay? All right. So, looking at this first one, so you can see I've got 7 square roots of 3, and I'm getting 6 more square roots of 3. And if you want to, you can factor out the radical if you'd like. Factor it on the back side right there so that then you can focus on, okay, 7 plus 6 is 13, and then square root of 3. Now, if you go directly here, that's fine. I don't have a problem with that. I'm going to go ahead and factor out the radical, but if you feel comfortable going from here to here, that's fine. But I'm going to take that extra step, and so you just decide what's right for you. So on this one right here, I'm going to factor out the square root of 17x. So I have 6 minus 8, and then I have the square root of 17x. So 6 take away 8, I'm taking away 8 from 6, so that's going to be a negative 2, and then I still have the square root of 17x right there. Uh-oh, looking at 37, look, they don't match. So I can't add these together yet. Okay, what I can do is I can manipulate and try to see if I can get a way for them to match. And so you always want to start with the larger one in this particular example. So let's see, square root of 8, I'm going to go ahead, I can break that up into square root of 4 times square root of 2 plus 3 square roots of 2. And then I can simplify the square root of 4 into a 2, so 2 square roots of 2 plus 3 square roots of 2. Okay, well that's good. Now I have matching square roots of 2 as my radical. So I'm gonna, this time since I'm running out of room, I'm gonna go ahead and just add the 2 and the 3 that are in front right here. So 2 plus 3 is 5, so I'm gonna have 5 square roots of 2. And there we go. All right, so the last two really aren't too different from number 37, except I'm probably going to have to do something with both of them, not just one of them. So if you look here on number 39, let's see, I've got square root of 50x minus square root of 8x. And so both of these are going to have to somehow get broken apart. And so what I can do with the 50 is I'm going to break off a 25, and that's going to leave 2x on the other one, right? Square root of 25 times square root of 2x, that'd be square root of 50x. And then on the minus square root of 8x, I'm going to break that up into a 4 times the square root of 2x right there. And then, let's see, 25, square root of 25 is 5, and then I got square root of 2x. Then I got minus, let's see, 2 square root of 2x. And then now I can go ahead and I can do 5 take away 2, which is 3 square root of 2x. And there we are. Okay, on 41, our last one here, pretty much the same as 39. So the only difference is I do have a 3 out in front. So remember that's 3 times square root of 18 plus 5 times the square root of 50. So I do need to somehow break both of those up. And so the square root of 18, I can break that up into a 9 and a 2. And then the square root of 50, I can break that up into a square root of 25 and 2. And so now I can go ahead and simplify both of those right there. And just remember, these are all separated by multiplication here. I do have addition, and then 5 times square root of 25 times square root of 2. So we're going to simplify each part individually. So let's see, this will become 3 times 3, and then I still have the square root of 2, plus 5 times, and then this 5 comes from the square root of 25 right here, and then square root of 2. And so now I end up with 9 square roots of 2 plus 25 square roots of 2. And so let's see, 9 plus 25, let's see, what is that? 34 square roots of 2. Okay. All right, so that's 3.4 square roots part 1. Okay, so we got a lot more of these to do as we move forward.